Well, hi, it's Rob Saik with another AGvisorPRO Podcast. And today we're going to learn about fertilizer, particular new types and new delivery of fertilizer. Did you know that fertilizer hasn't really changed since 1940? When you think about the delivery mechanism, we're talking primarily of salt delivery, oxide delivery, or chelate delivery. Well, today we're going to be talking to Jason McNamee, who's the COO, and biogeoscientist and one of the founders of Lucent Bioscience. And we're really excited to have him on board. Jason, tell us a little bit about you. Well, first of all, why should farmers care about what we're going to talk about on this podcast?
Yeah, I mean that is the $1 million question there, Robert. Really, and you did address it a little bit in the start, and that is that the core of fertilizer technology has not improved or changed appreciably since the 1940s with the Haber-Bosch process. Most of modern agronomy is predicated on the dissolution of salt when it comes to fertility.
Yeah.
That means that when that salt dissolves, is it at the right time for the crop? Not usually. And so what we find with modern fertilizers is that we only get 30 to 50% efficiency. The rest is either tied up or it off gases, but it's not very efficient. Now, I also want to say that without those, Rob, without those modern fertilizers, you and I would not be having this conversation because we probably wouldn't have been born. I mean, we need to be very grateful. We need to be grateful for that technology.
That's an interesting point, because Thomas Hager in his book, The Alchemy of Air, says that 50% of the protein in every man, woman, and child on the planet comes from fertilizer. So it's very important to us. Hey, listen.
100%. Yeah.
Jason, your degree is biogeoscientist. That's your title, biogeoscientist. I want you to talk a little bit about that and we'll fold it back into Lucent Bioscience. But what the heck is a biogeoscientist?
We're pretty rare. I'm somebody who started out in genetics in university, and I found myself in my later years of university spending a lot of time in a dark room. And I didn't really like that too much because I'm a Saskatchewan kid. I grew up hunting and fishing, and I like that. And so I started taking some geology classes, and I kind of ended up with these two different degrees, but they're all connected. I mean, geology is the history of the earth, the rocks that we walk on. Like, for example, if you think about, we often don't think about these things, but in the Western Canadian Sedimentary Basin, where we get all of our oil and gas in Western Canada, well, all of Canada, really. And you think about Banff, all that used to be the bottom of an ocean. I mean, we need to think about that. All used to be the bottom of an ocean, but it's that bottom of the ocean that produces our oil and gas. So we need to understand these biological and geological connections, because that really is the evolution of our species.
Well, interesting. Okay, so you're this cross between rocks and living, which is kind of a cool cross. You're in North Battleford, Saskatchewan today, so Heidi ho to you in North Battleford. And I want to just open up by figuring out who the heck and what the heck is Lucent Biosciences, and why did you found the? I think you founded the company in 2014.
Yeah, that's right. That's right. And it's a long story. We've been around for quite a while, Rob. But we were originally a deep sea research company, actually, and we were looking at a different problem of how to feed nutrients to plankton. And because getting nutrients to plankton so you can have photosynthesis is very difficult in the ocean, because we get oxidation very quickly. And when we get oxidation, the oxidized minerals like iron oxide or zinc oxide are not biologically available. We have to break that bond. So we were trying to find a way to deliver nutrients in such a way that they wouldn't oxidize, but they would yet always remain bioavailable. And that's what we did. The funny story is we were growing a bunch of plankton in our lab in 2018 after we figured out this technology. And one of the the professors at the university said to us, "What are you doing there?" So we told him what we were doing. He said, "Wow, that's cool. I bet that would work great for regular plants too." And I went, "Oh, that's pretty obvious." So we started running trials, right? And since that time, we've run well over 300 trials, mostly swap mapped, replicated, full field trials to figure out how, why, when, and where our technology is going to deliver the optimal ROI for our end user, the farmer.
So what is the problem that you were trying to solve? Like, I mean, obviously you're going after the 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 ocean side of the equation when somebody walked in and said, "Hey, what about land?" And you go, "Oh, that's but what is the problem that you are trying to solve? We talked about 30 to 50% efficiency
Yeah,
of fertilizer. We talked about salt index, etc. What is it that you are passionate about trying to solve?
it is fertilizer efficiency.
Okay.
So our products are water insoluble. They don't tie up, they don't leach. So as a modern agronomist, you should then say to me, well, if it's not a salt and it doesn't leach and it doesn't, dissolve, well, how would those nutrients ever get to a plant? Well, our products are 75% carbon. In fact, we get oat hulls from AGT Foods and Ingredients. They have a oat processing facility in Aberdeen. We hammer mill those hulls into a very fine powder, and they form the basis of the chemical reaction. And so we create a covalent bond between the cellulose fiber and the crop nutrition, and that goes into the ground. Now, what does the soil microbiome need to eat? It needs a carbon-based source.
Yeah, that's true.
And in our product is a very fine, very high surface area. And what ends up happening is when your soil is warm and moist, the soil microbiome starts to cycle. It eats our product, and our product then becomes part of that microbiome, which gets delivered to the plant. And so you get 100% efficiency out of our fertilizer uh, uh, throughout the fertilizer's life cycle.
Huh. So let's get squared away on what the product is called. And
Yeah.
I already learned something here. You are using oat hulls as a binding agent delivery method. So we're talking a granular product here, and what's it called?
It's a dry granular fertilizer. It's called Soileos, so soil EOS, Soileos, and our products are about 75% cellulose fiber. Now there's some residual protein and starch because the dehulling industry is not imperfect, so we do get some protein and starch in there as well. But then it would be about 10% potassium, about 5% uh, uh, sulfur, and then about 5 to 10% of a micronutrient product. Like as we have a zinc product, we're super excited. We just got copper registered in Canada, and we have a zinc boron product that is just awaiting registration. We hope to have that by November. We also have an iron product, which goes primarily into the soybean industry to address iron deficiency chlorosis. And we have a manganese product.
Wow, so this has really advanced a lot since we last talked. I think I was talking to Michael, your CEO in Europe, I think, last time. Now, so you got about 10% potassium, 5% sulfur, zinc, for example. What would be the concentration of zinc in soil Leos?
Our Soileos, our guaranteed analysis is 9%. It's a little bit
Okay.
higher than that, but our guaranteed analysis is 9% in the zinc product. So
Talk to me a little
typically,
bit. Zinc is really important for the legume crops that we are growing. You think about chickpeas, lentils, pea crops. And that's really important. But also copper. Copper deficiency across Western Canada is big. Tell me a little bit about your copper product.
yeah, that one is 5.5% guaranteed analysis. Um but we've done a ton of trials with it, primarily on cereals, which seems to be the heaviest user. But we do well with other crops if there's a copper deficiency in your soil. And that's a funny one, actually. I find it odd that a lot of people don't soil test still, which, if you have a soil test, then we know whether you have a deficiency or not and whether you should use our product. Uh, but let's go back to, you were asking about the copper. The copper works fantastic on cereals, but particularly where you have a known copper deficiency.
Well, this is very exciting. As you know, my history is micronutrients. I spent a lot of time in the oxysulfate and the chelate side of the equation. But the challenge has always been dispersion. So how do we get an even enough dispersion? Say you're going to target a 2-pound actual copper application in a crop. There's a number of considerations. One is, the concentration of the copper. The lower the concentration, like your 5%, the better the dispersion. The other consideration is the availability. So an oxide is very slowly available. Sulfur oxysulfate is a little bit better. Then you get into the chelate, so you're talking lots of money. So this makes a lot of sense to me. This is a really big news story for me that Soileos is now available in copper format. So you got some potash, sulfur, copper, and you got manganese. Manganese is really important for oats crops. So there's that too. So what are you seeing in the field, Jason? Well, first of all, if I'm a farmer, how do I use your product? Like, does it come in bags or mini bulk, or how do I get it?
It really depends on what your situation is, right? Because different growers have different needs, have different equipment. Typically, what we are doing is we are selling to retail, and we're bulk blending with MAP and maybe a source of sulfur and going down in the seed row in the spring because we have very low salt index.
Yeah.
That I would say is probably about 95% of our sales. We do have uh, 1-ton bulk bags, which we've had to refine over time because we didn't really get the scale of equipment. And, our bags were too big, but they're good now, by the way. But we've also got 50-pound bags for those who require it. And but we're primarily selling through your local retail. But if you don't have a retail that's near you that is selling our product, we're with the Federated Co-op retail system, and we're with most of the independent retails in Saskatchewan, Alberta, Manitoba, and Ontario.
As an agronomist who worked directly with farmers, I didn't sell fertilizer. We worked directly in advisory services. Our reputation was always on the line. When we soil sampled and we found that copper levels were low on a field, or zinc levels were low in the field, and you got the farmer convinced that it was a strategy that we should attack copper deficiency, the next real big risk was, does it work? And very often it didn't work for a couple reasons. One is that the farmer didn't put on enough. The second one is the product simply didn't release in time. So these are two really big factors as an agronomist. And one of the things that I wanted to push on this AGvisorPRO podcast was the connectivity of agronomists to Lucent Bioscience on AGvisorPRO. So download the app and connect with Jason and Lucent Biosciences on AGvisorPRO. But as an agronomist, you've got your reputation on the line that this stuff should work, right? And so how wide a field have you been field testing the product, Jason?
Well, I sort of mentioned it a little bit earlier, but we've run over 300 independent trials with about 100 and some with universities, like the small plot replicated trials, which are great to help you dial in your formulations and dial in your concentrations and make sure your product kind of works. But you cannot know how it really works, where you're going to see the best advantage until you do replicated strip plot trials in fields, and we also swap map all of our trials. So we've run well over 200 of those trials so that we know which crops work best, what conditions the product works best in, and we can be confident that we can see our optimal ROI in year one.
So if you're out of all the work that you've seen so far, Jason, if I was to pin you down and say, okay, I got X number of dollars to spend with Soileos, and I'm going to try it on one crop to address one issue, where would I roll the dice?
Again, I would say, show me your soil test. Let's look at your fields and let's figure out where we're going to get where your problem areas are. Let's figure out what crops you're using. Let's look at the market and see where the most value is in those crops, and then we'll choose that particular field.
Okay, all right. What's the biggest misconception farmers, agronomists, ag retailers might have about bio-based fertilizers?
I don't think there are many. I think there's lots of bio-based stuff out there. Ours is really not a bio-based fertilizer. Ours is simply an innovation in the core of fertilizer technology. We are simply piggybacking on the natural soil biological conditions where we have the plant root interacting with the soil microbiome. I don't think there are any other fertilizers out there that do that. There are lots of bio stimulants, there's bio products out there, but I don't think there are any that have the same mode of action as ours. And in fact, you'll love this, Rob. Our patent is compositions, systems, and methods for delivery of an element in response to biological demand. No demand, no delivery. So and this is actually very key to this conversation. When most of our products that we have for fertilizer are salt-based of some sort. And so when is your soil mostly moist and wet? Well, in the spring. And how big are your crops? How big are your crops in the spring? That big.
It's emerging.
Right. So is that when they need the nutrients? No. So our products don't release when the soil's cold and moist because there's not very much biological activity. There's a little tiny bit. And so that there would be a small amount of release, but it's not when the optimal release. The release is when the soil is warm and moist. When does your crop need it? When the soil is warm and moist, when it's growing at its optimal. And that really allows you to maximize the genetic potential of those very expensive seeds that you bought the year prior.
I'm thinking about copper again, and I'm thinking about when the plant needs copper and what the function of copper is in the plant. And it's there to help strengthen stalks by strengthening the cellulose and hemicellulose inside the plants. So it makes sense to me that if you had a copper product going into cereal grains and you're trying to fight ergot and you're trying to make the crop stand up better, that release of copper closer to the time when the plant needs it makes loads of sense. Loads of sense. Hey, let's talk a little bit about your company. Tell me a little bit about your organization, how you structured it, where you guys are from, how you doing?
Man, it's been really a wonderful journey, to be completely honest. I'm originally from the Balgonie area of Saskatchewan. I went to Notre Dame. I was a hockey player for a number of years. I'm a University of Regina Cougar. Believe it or not, I'm a Balgonie Bison. Like I'm a Saskatchewan boy, but I spent with my degrees, I ended up doing geotechnical and environmental engineering and working on mines and roads and all over North America. Super fun work. But then, in 2004, I had my first kid, and I was like, this is not the world I want him to grow up in. And that's when I really started down this path of trying to find better methods, things, how we could improve. We need to get into the future in a much easier, nicer way. We formed this company when I was living in Vancouver in 2014 with my good friends, Peter Gross, Michael Riedike, and Jose Toku, and later Dr. Farnaz Norma-Humadian, who still serves as our chief science officer. We have in Vancouver, we still have about 20 people doing mostly R&D and engineering. We have 4 or 5 organic chemists, 2 or 3 agronomists. We have 3 research greenhouse chambers where so products flow out of the chemistry lab into the growth chambers, from there into the research greenhouse. And if they make it out of the research greenhouse, it flows out into engineering. And they say, well, we got a product that works. Can we make it? Like, can you make it and make a profit off? And can we help that world? So that's kind of where R&D is still stationed out there. But I moved back to Saskatchewan. I'm living in our old homestead at Fishing Lake, Saskatchewan.
Okay.
We manufacture in Rosetown with our manufacturing partners, AGT Foods and Ingredients, who couldn't be they're the best partner we could have ever found. And we manufacture out of Rosetown, Saskatchewan, and we distribute out of Rosetown, Saskatchewan. So that's kind of where we're at today.
Good. Well, it's so sum up, Saskatchewan farm boy working in the road crew decides to settle down with his family, Vancouver, starts working on the ocean. When somebody comes along and says, hey, what about all the millions of acres of farmland? You go, oh yeah, I should have a look at that. And you partner up and you guys start to team up with AGT. Well, I want to say congratulations to you guys. So this is an entrepreneurial journey. Michael and I talked a lot about how challenging it is. If you haven't embarked on the entrepreneurial journey to bring a new idea to the marketplace, you really have no idea how hard it is. So I want to congratulate you guys on that. If you're a farmer out there, this is important. Very often, you'll try something, let's say copper again. You got a copper deficiency. You try copper. It didn't work because you didn't put on enough or didn't use the right product, and then you dismiss it. It may be 8 years before you come around again to try it. Oh, that's the copper problem. Well, these guys are giving you a solution that's a biologically carried, oat hull carried delivery system that gives you good dispersion and virtually 100% utilization closer to the time when the crop needs it. As an agronomist, this is important for you. You want to be recommending products that are good for the environment and also have good efficacy. And as a retailer, I think this is a way to separate yourself from the oxysulfates and the sulfates that are in the marketplace. I think I did a good job summarizing that, Jason.
Hey, really good job. Here's another interesting thing. We just recently had a paper published in the journal, Open Journal of Soil Science, and it's entitled, I got to look it up here because it's a long title, but it's called Evaluating Carbon Sequestration and Soil Organic Carbon Enhancement with Innovative Slow-Release Micronutrient Products. So
that's a mouthful.
With our product, we actually sequester carbon. So in addition to delivering the right nutrient at the right time, we also see an improvement in soil microbiome health. We can say health, but we just see there's more food for the microbes. There's more microbes. Think about it like that. And so we do see that, but we also sequester carbon. So we spent a couple of years on this project. Again, research greenhouse, out to field trials, doing tons of soil sampling. And what we find is that our products actually can sequester somewhere all the way up to maybe 2 tons of CO2 equivalency per annum. So that's an interesting thing. That's not part of our really marketing strategy at this point. We're not really sure how that's going to pan out, but that's
a pretty big claim. 2 tons of CO2e per acre per annum.
Annum.
Yeah, if you could develop a protocol around that. I used to run a carbon credit trading company. So if you can do that and prove that in a protocol, then this would be another ancillary benefit of farmers using Soileos.
Right.
Rolls
And
up,
I think
rolls off the tongue. Soileos. Yeah.
you need a little practice, Rob. That's all.
Yep.
You say
Yep.
it more.
Yep.
Um,
I will.
but this really kind of goes back to like the whole rationale why we got together to do this in the first place is we really wanted better outcomes. We need fertilizers that are more efficient. We need fertilizers that are more efficient that produce a better ROI for growers. And if we can also improve soil microbial biomass and sequester carbon, that's a really powerful tool because, Rob, we're going to have to grow more food in the next 40 years than we've ever grown in the entire history of humanity.
Well, that's a good place to wrap this up. That's a call to action if I've ever heard of one. I want to thank you all for listening to the AGvisor podcast. We encourage you to download AGvisor Pro. The reason we built AGvisor Pro was this very purpose, to connect farmers and ranchers with companies and experts to get new insights. And we're very, very glad that Lucent Biosciences is on AGvisor Pro. And Jason, I want to thank you for being on the AGvisor podcast. We'll be sending this out by video and audio and a bunch of different ways. So best success to you guys. I'm really proud of you guys being a Canadian company and everything you're doing. You guys are awesome. Thank you so much.
Thanks for the opportunity, Rob, and I'm really excited what you're doing with AGvisor Pro. We need more innovation in the industry that is really useful to multiple levels of people in the industry. So thank you for that.
You're welcome. Thanks a lot.
All right. Cheers.